Alright guys, in this video we're going to be talking a little bit more about percent composition by mass and doing a few more calculation examples. So we'll start off with an example of, let's determine the percent of potassium and potassium sulfate. Just remember and be very careful that because potassium is a has a +1 charge because it's a group 1A metal, it has to have two potassium atoms to neutralize the -2 charge of the polyatomic sulfate ion. Okay, so we'll follow the same steps as we did before. Let's see. Inventory of all of our atoms here. 2 potassiums, 1 sulfur, and 4 oxygens. So we want to define the percent composition of potassium. We're going to take 2 potassium atoms times its molecular weight, which is 39.1 grams per mole, divided by the summation of the atoms times their molecular weights, which is going to be equal to 2 potassium atoms times 39.10 grams per mole plus 1 sulfur atom times 32.07 grams per mole plus 4, and again guys, this is because of the polyatomic structure of sulfate, 4 oxygen atoms times 15.99. Okay, so next what we're going to do is, after multiplying everything through, is we're going to get 2 times 39.1, which is 78.2 grams per mole potassium, over the summation of all of these, which is 174.22 grams per mole of potassium sulfate. Now remember, this is why keeping your units really comes in handy. Grams per mole cancels out grams per mole. So now we have, so now we have 78.2 potassium over 174.22 potassium sulfate. That's the ratio we want. So when we do the math, we get 0.448. Now remember, you have to multiply by 100. Percent is a unit, because what we're going to have is a percent of potassium. So we have 44.8% potassium to potassium sulfate. Okay. So let's do one more example. This next example is going to be a little tricky. Alright, so for this next example, let's look at the compound of barium permanganate. Its molecular formula is BaMnO42. Now, when you first see this, it may seem kind of daunting. When you see this, what you have to understand is barium has a +2 charge. It's in the group 2A metals. Permanganate is a polyatomic ion with a -1 charge. To neutralize the charge of barium, we have to have 2 permanganate ions. So that's why this 2 is here. think of this parentheses and this 2 as using the distributive property. When we take A and put BC, and BC is our permanganate, A is the 2, we're just going to distribute everything. So putting that into play, we'll take barium and make our inventory here. And again, this is why taking inventory of your atoms always helps when doing percent compositions. So we have 1 barium ion. Again, there's no subscript there, so we can assume it's 1. Per manganese, there's no subscript there, so we can say it's 1. Multiply it by 2, so we have a total of 2 manganese atoms. We have 4 oxygen atoms, but times it by 2, we get 8. Okay. So now we can determine our percent composition. Let's determine the percent composition of oxygen. Okay. So what we'll do is we'll do the same thing in our formula. Again, as daunting as it seems, you're just following the same steps. Just make sure that you always keep track of your atoms. So we have 4 O atoms times 15.99 grams per mole all over. We have 1 barium atom one barium times its molecular weight, which is, did not realize how much I was going to use this again, 137.3. Okay. Plus 2 manganese, which is, sorry guys, 54.93 grams per mole. Plus 8 oxygen atoms times its molar mass, which is 15.99. And when you calculate this, you're going to get, well, I made a mistake. Remember guys, it's 8 oxygen atoms. Okay? So it's 8 times 15.99, and you get 127.92 grams per mole O, all over 37.3 plus 375.08. Okay. Barium or manganate. Okay, and again, the units will cancel. You'll get the ratio of oxygen per barium per manganate. And when you do this ratio, you have to move 34.341, and again guys, make sure you multiply it by 100. Sorry, I was just looking at the time here. You get 34.1% oxygen per barium per manganate. Okay. In the next video, I'm going to do one more percent composition by mass one, but it's going to be very involved, so it's probably going to take the full 10 minutes. But the reason I'm going to do it is because I'm going to do each percentage of each atom, and then we can show you how when you do the percents they add up to 100%, and that's a good way you can check. Alright, so I'll see you guys in the next video. Thanks for watching.